Specific heat of a material is the amount of heat is required to change the material's temperature by 1 degree Celsius. Aluminum specific heat is high, which is a drawback, but it makes up for it for having the property to conduct heat well, which is something that cooks look for in a material. With the ability to conduct heat well, it allows a uniform heating temperature when you are heating up your food. This means your food will be cooked evenly throughout, which is very good. This ideal property for many cookware because many stoves have a circular heating structure or they have a flat surface which does not conduct heat well. This means that the stove are heating the food unevenly. Since we're using a Bunsen burner, this is very useful. Aluminum also has the ability to be easily cleaned well and it's very popular to cook with.
The reaction is a conduction heat transfer reaction. It's pretty cool. It goes through metals, and we're using burner for this. I know it's kind of creepy using a scientific burner for this, but some people use like propane or electricity, stoves, grills, charcoal, you name it, buddy. So, 1 second, let me look at my scripts. Okay, we used a burner where the heat in joules was
restarted, but give me like 3 seconds. So
restarted what?
We used a. So our beautiful mac and cheese would be nothing without the water or the sauce or the chemistry behind it, for that matter. So as you know, we have our pot here on our stove, and the heat is going into the water. Now, when the water boils, it will have reached 100 degrees and begin a state change. It will actually change physical state. If we let it boil off, it will slowly turn into a gas without changing temperature. It will change into a gas and then diffuse, move into the air, to use another word. So once this boils, we'll add in our mac and cheese. And then after we add in our mac and cheese, we'll have the sauce. Now that our water is almost boiling, I'm going to go ahead and add the mac and cheese.
Because it is a...
Alright. Ah, it's boiling water.
Wait, 10? You look really close to the water.
I got boiling water on.
Okay, now that we've strained the pasta, that's going to go cool off in the sink. I have 2 tablespoons of butter here, so I'm just going to put that in our still warm pot. Now, this butter is going to have a state change. Right now, it's in its solid form, and it's going to melt. The melting is part of a state change. Since the butter has a really low melting point, it melts easier at a lower temperature. So now it's changing state.
See, it's not that bad.
It's okay.
Okay, once the butter is melted, we're going to add 2 tablespoons of milk to the mixture.
3.
Okay, sorry, actually 3. 3 tablespoons of milk. And then you're going to add the cheese packet. So then another chemistry concept when you're making mac and cheese is the concept of solubility. So what happens is the powdered cheese dissolves in the milk, and this is an example of solubility. So basically the high temperature of the milk helps the cheese dissolve, and then the air pressure doesn't affect the solubility of solids. And so then the powdered cheese is made from cheese powder, starch, dried flour, and some other dried ingredients. And so all the dried ingredients rehydrate once they mix with the milk, and so they make a cheese sauce. This looks kind of gnarly.
So funny.
Oops.
Pasta.